Hey guys, welcome back. This is JC and stuff here. Today we're going to be looking at this Australian gold nugget coin. This is a $100 face value gold coin. It's a 1 ounce of pure gold, or at least 0.99999% pure gold. And this coin was minted. This one in particular was minted back in 1988. I couldn't find much information on this coin as far as like the specs on it. All I could find was that it was, according to the moneymetals.com webpage, this coin was supposed to be a diameter of 32.1 millimeters, and it should weigh about 1 troy ounce, as it says on its face value. And also on Wikipedia, the same information was found. I found that they have the diameter of it to be 32.1 millimeters and the thickness of it to be 2.65 millimeters. However, the Amex American Precious Metal Exchange website, the thickness of this coin is supposed to be 2.8 millimeters. So that's a difference of about 0.15 millimeters. So I'm not quite sure which website is the most accurate one. So what I'm gonna go ahead and do is I'm just gonna go ahead and try to test this gold coin for what it is. I'm just gonna go ahead and see if this in fact made up of gold, since I don't have a constant source or a reliable source per se. I'm just gonna go ahead and test the coin itself for its gold value. Okay, so first thing I'm gonna do, I'm gonna measure the weight of this coin to make sure that it's as close as possible to a troy ounce. It's supposed to be about 31.103 grams. So let's see how that goes. And this coin in particular, it's about 31.11 grams, as you can see. Let me measure it again, just to make sure. Yeah, it's about 31.1. Let's tear this and make sure that it's measuring the right. Yeah, about 31.12, which is fairly close to 31.103. Okay, so now I'm gonna go ahead and measure the diameter of this coin. I have my digital caliper here, set it to 0, make sure that it's properly calibrated. I'm gonna go ahead and measure the diameter, and it says it's about 32.03 millimeters, which is, I mean, it's close to 32.1, but it's not quite close. Let me see. Measure from a. So that's a 32.01 millimeters. So this coin is about 32 millimeters in diameter, not 32.1. Now we're gonna go ahead and measure the thickness of it and make sure it's our caliper is set at 0 again. Okay, so now we're ready to measure the thickness, and as you can see, it's about 2.48 millimeters. I'm gonna go ahead and flip that coin 180 degrees, and I'm gonna measure from the opposite end. That's about 2.51 millimeters. I'm going to go ahead and rotate it about 90 degrees. And it's about the same, 2.51. So I can safely assume that this coin is on average about 2.5 millimeters instead of 2.65 like the website says, unless I have a fake one. We'll find out about that later. Let's see. Let's continue our experiments. So now I'm ready to perform my volume test for this coin. The volume is going to help me determine how much the density of this coin, or at least to calculate it by using the weight and dividing it by whatever the volume of this coin turns out to be. So I'm going to go ahead and make sure that our scale is set at 0. And I'm going to go ahead and dip the coin inside the water, again making sure that there's no air bubbles trapped underneath. So I'm going to go ahead and drop it inside and with this pulley system that I have created, and making sure also that the coin does not touch the surface of the glass at any point. So let me just stabilize the coin a little bit. Okay, there you go. So should be about 1.6. Oh, sorry. 1.61. 1.62. My hand is not as steady as 1. So it's about 1.61 grams of water displaced. 1.61 grams of water displaced. So 1.61 grams of water displaced by this coin. And our weight was about 31.12 grams. So we're going to go ahead and calculate 31.12 grams, which was the weight of the coin, divided by 1.61 cubic centimeters of water displaced, or 1.61 grams of water displaced, which is the same. And that's going to give us about 19.32 grams per cubic centimeter. So again, this is the density of this coin. So now we're going to go ahead and, which is pretty close to 19.3. This is the value that we should be expecting, or around the value we should be expecting. This is fairly close to the density of gold, but then it is also close to the density of tungsten, which is about 19.25 grams per cubic centimeter. So we're going to go ahead now and do our final test. We're going to go ahead and use our handy ultrasound thickness gauge. Okay, so now I'm going to go ahead and measure the thickness of this coin using my ultrasound thickness gauge. But instead of doing the usual thickness measurement using the speed of sound through gold, I'm going to go ahead and dial the speed of sound through tungsten. I'm going to assume that this coin is in fact made up of tungsten, because that's the closest element to gold in density. So I've already dialed the speed of sound through tungsten, which is about 5,220 meters per second, and I've already calibrated my probe. So I'm ready to just go ahead and put some gel on the coin. I'm going to choose the center of it to measure the thickness of it. Let's see what readings we get. And make sure you have enough ultrasound gel and that your hand is as steady as it can be, so you get the most accurate result. So there you have it. If I measure at this point, it measures about 3.31 millimeters, assuming that this coin is tungsten. So now I'm going to go ahead and compare that to my digital caliper. So at the center of this coin, my caliper reads about 2.15 millimeters. Let's see, make sure that it is centered. Yep, it's at the center. It's about 2.17 millimeters, which is nowhere near to the value that we saw here previously, which was about 3.30 something. Now it's at 3.76. So it's really nowhere near. It's about a whole millimeter off. So now we're gonna go ahead and change this value to that of gold. So we're gonna go ahead and dial in gold, which is about 3,240 meters per second. So now I'm going to measure the thickness of this coin using the speed of sound through gold. So let's see how that goes. Again, put a little bit of ultrasound gel at the center of the coin. Put my probe on it with the steadiest hand as I can, steady as possible. And it measures about 2.13 millimeters. So 2.13 millimeters. So again, we're gonna compare that to our readings on the caliper. And then again, now it's reading somewhat a lot closer. A lot closer. So I can safely assume that this coin, in fact, on the inside is made up of gold and not tungsten. So 2.14 millimeters. The reason as to why I did this test is because there's really no reliable source as to what the dimensions of this coin should be, and there's really not much information that I could find out about it. However, if you guys have any suggestions or any other way of finding out the exact values as to how this coin should be measured, I would be more than glad to redo this video and use those values if somebody out there knows about these values. But in the meantime, the only thing I can rely on is my the density test and the ultrasound thickness gauge, and maybe the acid test. But I do not suggest doing the acid test on these coins, as they're you want them to be as close to mint condition as you can, because they could lose value. So again, thank you guys for watching, and I hope you guys learned something new. I did learn something new with this coin. I didn't know there wasn't that much information about these coins, or at least that's accurate. Oh, one thing we forgot to do also. Here's our neodymium magnet, and it's not magnetic. And we can also do this ping test. And again, if you can hear that ping, like gently tap the coin. I hope you guys can hear the ping. Okay, so there you have it. Those are the only tests that I can rely on. I can safely assume that this is in fact made up of gold, but I don't know if this was an actual minted coin, if it was actually minted by the Pert Mint, as the websites suggest. So if you guys out there, anybody has any information, I'll be glad to get any suggestions. Again, thank you guys for watching, and see you next time.